In this video, we are looking at how FastAPI handles HTTP headers and cookies. Every web request carries metadata beyond the URL, things like authentication tokens, language preferences, and session identifiers. FastAPI gives you a clean declarative way to read all of that and to write cookies back to the client without reaching into the raw request object by hand. Without a framework helping you, reading a header like authorization or accept language means writing something like request.headers.get, passing in an exact string key, and handling the case where it is missing yourself. Do the same for cookies, and you are now juggling two separate raw dictionaries. There is no validation, no documentation, and plenty of room for a typo to cause a silent bug. Here is a way to picture it. When a letter arrives at a hotel front desk, the staff do not hand the guest the entire postal system. They read the envelope, pull out the relevant information, and pass it along in a useful form. FastAPI does exactly that for your function. It inspects the incoming HTTP envelope, extracts the header or cookie you declared, validates it, and injects it as a named parameter. FastAPI extends its dependency injection style to headers and cookies through two special classes, header and cookie. You use them as default values on your function parameters, exactly like query or path. When a request arrives, FastAPI knows to look in the right part of the HTTP message for each one. The underscore to hyphen mapping is a small but important detail. Because Python identifiers cannot contain hyphens, writing except underscore language automatically targets the except language header. Starting at the top, we import FastAPI, then header and cookie from FastAPI, and JSON response for the login route. In get underscore profile, the parameter authorization uses header with a default of none. FastAPI, I will look for the authorization header and inject whatever it finds, or none if it is absent. The parameter authorization header accept underscore language maps automatically to the accept language header because FastAPI converts underscores to hyphens. The session underscore ID parameter uses cookie, so FastAPI looks in the cookie jar of the incoming request instead. In the login route, we build a JSON response manually, then call set underscore cookie on it to attach a set cookie header to the outgoing response, marking it HTTP only, so JavaScript cannot read it. When a request arrives, FastAPI's dependency resolution layer examines each parameter default before your function is called. For header, it converts the Python name to a hyphenated key and looks it up in the request headers dictionary. For cookie, it uses the name as is against the past cookie store. If a required header or cookie is missing, FastAPI returns a 422 unprocessable entity response with a clear error message. You do not write that error handling yourself. As a bonus, all declared headers and cookies are included in the Open API schema FastAPI generates. Header and cookie shine when you know exactly which values you need and you want FastAPI to validate and document them for you. They are a natural fit for reading an auth token, a language preference, or a session identifier. However, if your security logic is complex, FastAPI's OAuth 2 and HTTP bearer security schemes are a better starting point. If you need to read every header that arrives, say to proxy them wholesale, just use the raw request.headers object directly rather than declaring dozens of individual parameters. To wrap up, header and cookie follow the same declarative pattern as query and path, so there is very little new syntax to learn. The underscore to hyphen conversion handles the one naming mismatch between Python and HTTP. Validation and error responses are automatic, and your declared parameters appear in the OpenAPI docs. When you need to write a cookie back, build or inject a response object, and call set underscore cookie on it before returning.